Hello guys, I'm a teacher Limboka Nsajiga Masame. Welcome to Limboka Physics. Let us have a look on a question below from Itai concerning vectors. Question 12, revision exercise 1. We have given a passenger train, that is SGR, and a local train that are passing in such a way that they are moving opposite to each other. The passenger inside the SGR train sees the local trains. Now, the underlying word C is something of most important in attempting this question. We have given now the velocity of this train that is 360 kilometer per hour, and the velocity of this local train as 100 kilometer per hour. Consider the diagrams that elaborate these scenarios. This is a train for SGR train where the passenger is inside, and this is a local train that is passing against the direction of this SGR train. This is the velocity of passenger with respect to the ground, and this is the velocity of a local train with respect to the ground. And we've given the length of this local train as 315 meters, as represented here. Let us take the frame of reference from the mid where these two trains separate. We know that this passenger inside the local train is the one that records the motions of between his own train and a local train. And here we will have a relative velocity of the local trains with respect to the passenger. Now the passenger is an observer now, the observer in motion. Okay, let us see these presentations of vector diagrams. These vector diagrams represents the whole scenarios here. How they see we must have, as usual, the two sets of axes, that is frame of reference for the moving observer, that is a passenger inside the train, and the stationary observer that observing the absolute velocity of the trains where passenger is inside and the local train. Okay, this concept has been well described from my series of videos that explains relative motion between two objects in one dimensions. Just go and pass through those series and you understand clearly what is going on for each cases, for the same directions, for the different opposite directions, and the velocity, relative velocity when the object is in fluids. Okay, let us go directly to this formulas, as we will have a first vector here and we will have a second vector here, and the resultant vector is drawn from the tail of the first vector to the head of the last vector. And so we just use a vector addition rule where we add the velocity of train of passenger with respect to the ground plus the velocity of train with respect to the passengers, which is equal to resultant velocity, that is velocity of train with respect to the ground, or to the S. Okay, now we'll make the subjective velocity of train with respect to the passenger, as you can see here. Then from inertial frame of reference, not the inertial frame of reference, because who is recording the motion here is the moving observer. From moving frame of reference, that is O dash, the velocity will be recorded as the velocity of the trains is negative and the velocity of the passenger is positive as it's moved towards the right, while the train is moving towards the left. And the displacement of this train, which is equal to the length of the local trains, that is towards the left also. That's why the displacement O dash to O that is recorded by this moving observer, O to O dash, because as this velocity is same as it is come from O, and the displacement respective. And when you follow the step here, and after substituting the data, we'll find the velocity of train with respect to the passenger as negative. And we know that the velocity of train with respect to the passengers is equal to displacement divided by time. We are supposed to find the time for a local train to pass this SGR train as observed by passenger inside the SGR train. Now, our displacement as usual will be negative because it is towards the left, as from from the moving frame of reference. And then our answer will be as you see here below. Thanks for watching. Please like, share, comments. Don't forget to subscribe this channel for more video. Remember, this solution has been revised in this date. Thank you.